Today, we will simplify Newton's 3 laws of motion. We aim to make it understandable for everyone, even a goldfish. Ready? Let's begin. First, we have Newton's first law, known as the law of inertia. It states, an object at rest tends to remain at rest, while an object in motion maintains its motion unless influenced by an unbalanced force. In simple terms, if you're relaxing on the couch, you'll stay there until someone excitedly shouts, "Pizza's here!" That shout acts as an unbalanced force, changing your state of rest. This can also be seen with your skateboard. Give it a push, and it will roll until friction, gravity, or an obstacle stops it. Without friction, it could theoretically roll indefinitely. Inertia primarily relates to resisting any change in motion. Next, let's discuss Newton's second law, termed the law of acceleration. This law explains what occurs when force is applied. It is summarized as force equals mass times acceleration, or in mathematical terms, F equals m times a. Here's a simple demonstration. Let's take a toy car. If you give it a flick, it races forward. But if you add a small weight, like a mini sumo wrestler, the same flick barely moves it. Why is that? Simply put, greater mass results in less acceleration when the same force is applied. Think about pushing a shopping cart versus a rhinoceros. It is crucial that you don't actually try to push a rhinoceros, as zoo staff might object. In summary, greater force results in increased acceleration. Heavier mass decreases acceleration under the same force, unless you exert much more force. Finally, let's cover Newton's third law. This well-known law states, for every action, there is an equal and opposite reaction. If you've jumped off a skateboard and seen it move back while you move forward, you've witnessed this law. Alternatively, you may have experienced a boat's movement when stepping off and ended up in the water, as the boat recoiled in the opposite direction. This law is vital for rocket propulsion. The engines push hot gas downward, resulting in the rocket ascending. Action and reaction occur simultaneously. Understanding this principle allows us to launch satellites, explore Mars, and sometimes lose our shoes while jumping on trampolines. Let's summarize. First law: a pizza remains on the plate until acted upon. Second law: the heavier the pizza, the more force required to eat it. Third law: dropping pizza triggers a dog's rapid movement towards it. Action: pizza falls. Reaction: dog darts forward. Physics isn't reserved for scientists or astronauts. It explains why your ice cream spills instead of hovering, why airbags deploy during crashes, and why rolling office chairs should not go downhill. So, dear students, remember, each time you move, stop, or send your lunch flying, you are applying the laws of motion. Use this knowledge carefully, and perhaps keep snacks away from edges. If you found this informative, give us a like, subscribe for more engaging content, and share your favorite observation of Newton's laws in action in the comments.